Okay, so we're going to talk today about cognition. It's in relationship to language development and intelligence, because our cognition is anything that any thinking, thought processes, reasoning, problem solving, sometimes even included would be like decision making. There's a lot that goes into our cognition. So think about pretty much almost anything that you do with your brain, so to speak, or what you would think of as your thoughts. Now, our thoughts, again, take on, thinking takes on many things. Daydreaming is part of thinking, again, problem solving, reasoning, communicating, making decisions. Thoughts is mental categories that we put things together. Now, the basic units of our thinking are concepts. Okay, concept is like a category of something. So you have a concept for what a chair is. You have a concept for what a computer is. So our thoughts are usually in these concepts. And concepts are often made up of a prototype. Now, a prototype is kind of like the generic for the category. So you have kind of like you have a prototype, let's say, for a chair, what a chair is. A chair is something, the prototype may be something like it has a seat. You have to have a place to sit for it to be considered a chair. It has legs underneath it to support that seat. And that may be basically it, because a chair can basically have 3 legs, 4 legs, 6 legs. It can have a back or not have a back. It's still often considered a chair if you can sit on it. So that would be your prototype for a chair. And our concepts are usually in prototypes, because a concept is a category of things which we have a prototype for. And that's what makes up our thinking or our thoughts. Now, reasoning is part of cognition. And our reasoning is how we solve problems. So it's using our information to solve a problem, sometimes even make decisions about certain things, has to do with our reasoning. Okay? There are 2 different types of reasoning: deductive and inductive. Okay? So deductive reasoning is when you start with a large picture, a large assumption about something. So we have a large assumption about something. We believe our assumption to be correct. And from that large assumption, we draw conclusions. Okay? So let's say that your assumption is that you have to be 21 years old to drink. Okay, so that's the law. And so your assumption is that you have to be 21 years old to drink. So you see somebody drinking alcohol. Your big assumption is then that only people who are 21 can drink alcohol. So your conclusion is about the smaller subject, which is that actual person, is that they're 21 or over. Now, are we always right? No, we're not always right. Deductive reasoning isn't always right. But again, the basic of deductive reasoning is that you take a large assumption, and from that, you make specific or smaller conclusions based on that large assumption. Now, inductive reasoning is just the opposite. So you take a specific thing and then you make a large, big assumption about everything else based on that one specific thing. So for inductive reasoning, you see somebody drinking and you know for a fact that they're 18, but you see them drinking alcohol. So based on that specific situation, you draw the large conclusion, the bigger picture, that you only have to be 18 to drink alcohol. Again, are you always going to be correct? No, but it's 2 different ways of reasoning: deductive and inductive ways of reasoning. Okay, then we have problem solving. Now, problem solving involves searching, trying to figure out strategies, rules, different things to reach a goal. Because when we're problem solving, we're trying to reach a goal. The goal is to solve the problem. So that's what we're trying to do. Now, with problem solving, there's several different things involved. So cognition involves all of these. Now we're going to talk specifically about problem solving. And since my black marker isn't working all that great. I'm going to try a different color. So we have methods of problem solving, we have rules of problem solving, and then we have pitfalls. Pitfalls are problems with problem solving. Okay, I know it sounds kind of odd, but we have pitfalls. Okay, so problem solving. When we first come across a problem and we're looking for a way, a method to solve this problem, I'm going to move this a little closer in hopes, I know this is blue ink, that you can see it a little bit better. Back up a little bit. I'm not very good at this. Again, this is kind of new, all new to me. I'm not used to doing all this, but anyways, it's all in your book and we're going to talk about it. So, methods of problem solving. Usually, when we come across a problem, the first thing that we do is trial and error. Trial and error. We just try a bunch of different things and see what works. It's not usually very efficient. Trial and error doesn't usually work. You know, maybe you've come across this where your computer freezes up, and so you just start pushing buttons. You know, Control Alt, do this, do that. It worked before. I'll try this. But eventually, sometimes none of those things work. But that's what we go to first, because if it works, then great. It was quick, it was easy, we got it taken care of. But often that doesn't necessarily work all the time right away. Okay. And sometimes it takes too long as well. Problems or trial and error can take a long time. Then we have insight. Insight is when we're trying to solve a problem and it seems as if, we're working and we're working on this problem and we're trying this and we're looking at that and we're going all over the place. And then it's like all of a sudden the light goes on and we got it. It seems like it's all of a sudden. That's why we call it insight. It's like, oh, okay, I get it now. Now, if somebody asks you if you come to the conclusion and you solve the problem, and then somebody may say, well, how did you come to that? I don't know. It just came to me. So it seems like it just comes out of the blue, like it just comes from nowhere. But usually it's actually accumulation of everything that we've already tried and all of the things combined together. We've tried this and we've tried that. We're looking at this and we're looking at that. All of a sudden it all just falls together and we have the solution to the problem. So it's kind of like that aha moment. I get it. It's sudden. Again, it seems like, we don't know where it came from, but it's usually accumulation of everything that we've been doing. And that's called insight. Okay. Then we have, it sounds kind of odd, but we have rules for problem solving. Rules for problem solving. And we're going to talk about two of the rules. Algorithms. Algorithms is a fixed set of rules. It will always lead you to the solution. It's like the instruction book. It's like if you were going to drive a car, how to drive a car instruction book. If you got a new entertainment center and you pulled out the instructions and you followed A, B, C, D, and you did the instructions exactly the way it says, that's an algorithm. Okay. Now, the problem with algorithms is that it's a slow process. Many people will, just, they give their entertainment to center and just start putting it together and, oh, this goes here and this goes there and, try to do it. And then they may end up with a few pieces left. And that's not such a good thing. But if you do algorithms and you follow the directions, it will be put together and it will be done correctly. And it works very well with well-defined problems. When you have a problem and it has an instruction, it's great. Algorithms work great with that. It can be a slow process, but again, you will get to the answer and you will solve the problem. Sometimes the instruction book isn't available. So you kind of have to maybe figure it out on yourself. So if you can't, if you don't have the instruction book, then you can't use the algorithm. Okay. This is heuristics. Heuristics is like a rule of thumb, like shortcuts of how to do something. And we have two different types of heuristics: means to an ends and analogies. Okay, so a heuristic is, again, a rule of thumb. It's a shortcut. It makes problem solving easier, quicker, if we can use a heuristic, if we can come up with something. The means to an ends is that we take a large problem and we break it down into smaller problems. We solve the smaller problems, and then eventually the big problem is solved. That's a means to an ends. Taking a large problem, breaking it down into smaller ones, solving the smaller problems, eventually the big problem gets resolved. Means to an ends. The second heuristic is analogies. An analogy is when you've solved a problem, the problem that you're trying to solve, you've solved a similar problem in the past. So you kind of know how to do it based on your problem solving from the similar problem. And so you apply the same thing that you used before to now. So let's say, again, you got that entertainment center from IKEA and you've put together an entertainment center before, your friends, so it all looks very familiar to you. It's similar to what you did before, and so you get it put together quicker than using the algorithm. So you use the heuristic of analogies because you've solved a similar problem. Okay. Then we have the pitfalls. It sounds odd, but pitfalls to problem solving are the problems with problem solving. What are the things that get in our way? What are the things that prevent us from solving the problem? What gets in our way? Why can't we solve this problem? Or we think we've solved it. Often the pitfalls, when a pitfall to problem solving occurs, we think we've solved it, but in actuality, we haven't. And so obviously that becomes a problem because our goal is to solve the problem. And we think we've solved it, but we really haven't. So we haven't reached our goal. One of the pitfalls to problem solving is failure to analyze, meaning that we get the problem, we look at it, we analyze it, we solve it, and come to find out we have the wrong answer. Why do we have the wrong answer? Because we've analyzed the problem incorrectly. And you may have experienced this early on when you were doing word problems in math. So, you're reading the problem and you think you know where you're supposed to add and subtract and divide. And so you do all that and then you come up with the wrong answer. Why did you come up with the wrong answer? Because you analyzed the problem incorrectly. Maybe you added where you were supposed to subtract, or maybe you subtract where you were supposed to divide. And so you didn't get the right answer. And if you go on in psychology, you have to take statistics. And maybe some of you have taken statistics in high school. And one of the biggest issues with statistics, one of the big learning tools that you need to know in statistics, you have all these formulas that you can apply. But when you get the problem in front of you, which formula do you choose to apply to this problem? Which formula goes with this problem? Because if you pick the wrong formula because you analyze the problem incorrectly, again, you're going to get the wrong answer. So being able to read the problem, analyze the problem correctly, figure out what they're trying to figure out, that's what's going to help you. So one of the things that gets in our way of problem solving is we don't analyze the problem correctly. The next thing is that we think what we would like to think. In other words, excuse me, when we come to a problem that needs to be solved, we have in our mind what the solution is going to be before we even solve the problem. So we want it to come out in a particular way. So we kind of make it come out that way. And this happens a lot, again, with, when we were talking about research methods. And one of the things that we talked about with research methods was that the researcher is very connected to their hypothesis. They want their hypothesis to come out, so they make it so that the hypothesis comes out, and that's that we think what we want to think. We didn't really solve the problem, and so what happens then when other people analyze our research and they look at it and they say, this isn't, you didn't do this correctly, you fudged it, you saw what you wanted to see, but you ignored this and you ignored that, and you had researcher bias, and you had those things that got in the way of your solving the problem because you were so vested in it coming out the way you want it to come out that it got in the way of your actually really solving the problem. So we think what we would like to think. And the last thing is called functional fixedness. Fixedness. A little bit of trouble with that word. Functional fixedness. Now, what functional fixedness means is that we see an item and we believe it only has one function. So we are fixed on the function of this pen. The purpose of this pen is to write on a whiteboard. Okay? Now, I want to write on a piece of paper. I want to leave a note. I don't have a whiteboard. The whiteboard I left at work, but I want to write a note to my family. And all I have is this dry eraser pen. Now, if I'm stuck in functional fixedness, I don't think about that this pen can also be used to write on paper. Okay, now I'm stuck. I can't solve my problem of leaving a note for my family. I have a dry erase marker. I don't have a dry erase board, but I have a piece of paper, and I don't think about the fact that this dry erase marker can also be used to write a note to my family on a regular piece of paper, not just a dry erase marker. Okay. I saw this recently with the whole, in the beginning of the COVID-19, pandemic, and people were freaking out and buying things. And and they were hoarding and afraid to run out of things, or I don't know, they were buying, you saw, if you watch the news, you saw people coming out of the store, especially Costco, with, big, huge packages of toilet paper. And they would maybe have 5 of those big, huge packages of toilet paper. So then other people would be coming in, the toilet paper shelves were empty. And so people were panicking. They couldn't find toilet paper. What am I going to do? I can't find toilet paper. I need it. It's a necessity. It's a necessity. So I remember going to the store and the toilet paper shelf was empty, but you know what? There was plenty of tissues, Kleenexes, boxes of Kleenexes. So to me, and people were asking the store clerks and stuff, when are you going to get more toilet paper? I need toilet paper. When are you going to get toilet paper? When all they had to do was buy a Kleenex box. You can use it as toilet paper. But if you get stuck in this functional fixedness, you think that a Kleenex is only to blow your nose with, not to be used as toilet paper. And so therefore, if your problem is, I need toilet paper, the store doesn't have any toilet paper, what am I going to do? And you're stuck in functional fixedness, it's going to prevent you from solving your problem as to how to clean yourself after you go to the bathroom. So people get caught up in this functional fixedness, and it prevents them from solving problems. Okay, so this chapter, we have we have cognition, we have language development, and we have intelligence. So 3 different topics. I've done 3 different lectures on this, so that you can watch them again at your leisure, and then so that will cover this chapter completely.